Good morning. I am Prasannanjaneya Reddy, working as Assistant Professor in the Department of ECE, IARE, Hyderabad. In this session, we are going to discuss about embedded system design process. How we can design the embedded systems. So different persons or different authors or different companies follows different methods. One of the standard method is we are discussing now. So first, why we are following particular method, why we not for others means this development process takes some development time. This development time reflects the company margin. Suppose in the mobile browsing speed point of view, in that point of view, we are discussing one example. In the beginning days, we are using 2G network for browsing purpose. Later on, 3G introduced in the market. At that time, the handset which supports 3G that will sells maximum number. Later on, Jio introduced 4G network. While Jio introducing 4G network, whatever the companies they release the 4G handsets, they will be purchased first time. So in India, one of the main is average income. So they are not preferred to purchase the latest products up to date most of the times. So whoever first purchases the product that will be used maximum time. This is the main thing in the India. Okay, if you want to business in India, whoever first release the product into the market, they will get their products will be sold maximum. Automatically, they will get maximum margin. That's why how we can release the product first means we need to check the development time before starting the design. So we need to check how much time it will takes for release the product into the market. That is very, very important. If you release the product within that time, maximum number of products will be sold and will get maximum margin. Otherwise, that will be reduced as day by days going on, as days are going on. Okay. So before going to design, we need to consider some basic points. One is design the right embedded system and release that product into the market, in the right time. Okay. Right embedded system in the sense that satisfy the features of the customers, that satisfy the customer requirements. Example, Nokia Basic Mobile is popular in India when comparing with other manufacturer or companies' basic mobile phones. Why means if the mobile is dropped into the surface, it does not affect that much when comparing with the effect of the other mobile products. And the battery life is long when comparing with other manufacturers and strong. Okay, so most of the common people will prefer basic mobile point of view. In that point of view, Nokia will be preferred when comparing with other brands. If they want maximum performance or speed, at the time most of the people prefer Apple iPhone because that provides that much of speed, performance, reliability, and so on parameters instead of cost. So in what point of view we are designing the product, either maximum speed and performance or cost. Like this we can consider under all these points and design the right embedded system and release that product into the market in the right time. That is one of the point. Next, we can design the products as that product provides maximum performance with medium cost. Suppose if you are providing maximum speed and performance along with maximum cost, means that margin is different, little bit only. Few people only purchase that one. Like that. So design the embedded systems as maximum performance with medium cost. At the same time, medium performance with low cost. In this manner, we need to design the embedded systems. First, design the right embedded system and release that product into the market in the right time. Second, provide the maximum performance with medium cost. And third one, provide the medium performance with the low cost. In this manner, we need to design the embedded systems. Next, coming to the design process, embedded system design involves 7 stages. Okay. So first stage is product specifications. Product specifications. So what is the requirement? What we want to design? So as per customer point of view, we need to check. So for this, the companies form a team and visit the company outlets. So what is the customer requirement? Before going to the survey, they form the questions manner. They prepare the questions, small questions like what is your requirement, is it satisfying, like that, you are expecting any more, like that. They are preparing the questions in the question manner. Okay. Next, in the team, one person is manager, 2 persons are marketing people. Like that, they form one team. The team contains manager, product manager, and marketing, 2 marketing people. They visit the company outlets or outlets. There, they will get the answers to these questions, and they will survey with people. After completing the survey, they are conducting a meeting. In that meeting, they conclude that one. So what is final requirement, final specifications that needs to be designed? Okay. First, the company form a team. The team contains one product manager and 2 marketing people. Like that, they form a team and visit the company outlets. Before going to the survey, they form the questions, prepare a questions for surveying the people, what they are expecting from the customers. After surveying, again, all groups or all teams conduct a meeting. In that meeting, they are concluding the specification that needs to be designed. It is very, very important stage. Once finalized, we need to invest so much money, manpower, and so on. Once if you are started, again we want to modify, means entire thing, previous work is wasted. That's why here we need to take care, we need to consider very care. Okay. After final conclusion like that, they designed the right embedded system, release that product into the market in the right time. Second, design the product as that provides maximum performance with medium cost, and medium cost with the sorry, low cost with the medium performance. Like that, we conclude the specifications. Final conclusion. Product specifications is the first stage. Then, after finalizing the specifications like 32 megapixel camera, 108 megapixel camera, or that provides maximum speed within fraction of a second, that needs to be the task must be completed. Like that, once finalize the specifications, that specification needs to be designed by using either hardware or software. Because if you are considering hardware that provides maximum speed, hardware execution is always faster than the software execution. So, what is our requirement? Maximum speed is the requirement, or cost is important? So, in which point of view we are designing the product? Okay, suppose if you are designing the product using 8086, at that time, if you want to do the floating point operations, that needs 8087 processing element that is externally available. For doing that operation, if you are using external hardware, that provides maximum speed. Okay, provides maximum speed. At the same time, the cost increases, whatever the cost of the 8087 floating point processing element, the size of the overall system increases. Then heat dissipation increases, size increases. So we need to consider these points. We want speed or cost. If you want to provide maximum speed, we can use 8087 floating point unit. Or if you want to provide product as low cost, we can use instructions for doing the same operation. Okay, like that we can partition the requirements or specifications. That specification needs to be implemented by using either hardware or software. Here we are using embedded system co-design process, or you need to consider our parameters, speed or cost. Next, third stage. Third stage. In this third is after specifying or partitioning the requirements, that particular requirement is implemented using hardware, like image processing, signal processing applications are implemented by using a digital signal processing element, and basic arithmetic operations are implemented by using instructions. Then again, that requirement is divided into individual parts, small teams like small parts. Then that individual requirement is implemented until we are getting the desired response. That is called iteration. Iteration means repeatedly modifying. Iteration means repeated. Iteration means repeated. What is repeating here? We need to modify the design. Why we need to modify? Until getting the desired response. Suppose I want 1 plus 2 equal to 3 is a requirement. But after executing, suppose I am getting 1 plus 2 equal to 2.9 means, is it valid? No. Exactly we need to get 3.0. Other than 3.0 means the design is not getting the accurate result. So accuracy is important here. So until until we are getting the desired response, we need to modify the design and verify the response. In this process, we can use different tools. So based on the processing element, suppose I am using 8051 microcontroller. At that time, the manufacturer will provide the IDE tool, integrated development environment tool. So if you want to design the application on particular processing elements, you need to know the features, architecture, memory organization, instruction set, addressing modes, interrupt structure, or types of minimum mode and maximum mode operations like that. We need to know each and everything. Then only we can design the design the requirements efficiently. That takes much time. So to reduce the development time, the manufacturer of the processing element, either 8051 or Intel, Atmel, Texas Instruments, NXP Semiconductor, Philips, Apple. So whatever the processing element we are using here for this requirement, the manufacturer itself provides the tools to reduce the development time. In these tools, we are using corresponding language and design the requirements. Suppose if I want to design the applications using 8051 microcontroller, in this case I am using Keel IDE tool, and here I am using C language, embedded C language for designing the applications. So first choose the processing element. Based on the processing element, the manufacturer provides the tool. In that tool, we are using corresponding language to reduce the development time. Instead of learning architectures, features, addressing modes, instruction set. So this learning time will be reducing here. Suppose if you know C language sufficient. As day by day going on, we are getting different types of advanced processing elements. Whenever changing the processing element every time, we are learning again instruction set, addressing modes and all these things means it takes some time. That leads to increase the development time. As development time increasing means our margin will be reducing. Okay, that's why suppose I am getting a 805 advanced version at the same for the processing element we are using kilo only, so no need to learning a instruction set. Simply one time I am learning C language, even processing element means change of related to the similar processing elements, no problem. Okay, that is the advantage of these tools. Instead of learning repeatedly of the latest advancing processing elements instruction sets, one language is sufficient of corresponding processing elements. Suppose I am using TM4C123GH6PM, this ARM processing element. Here also I am using Code Composer Studio. In that I am using C language. So no need to again learning new language. So here also I am learning C language, here also I am learning C language. Suppose I am using digital signal processing elements. MATLAB, image processing and signal processing applications. Here using YAM script. That is also similar to C language. So first choose the requirements what we want to design. Based on the requirement, we can consider which processing element is suitable for our design. Based on the processing element, they are providing corresponding tools. Keel, CC Studio, or MATLAB, or Xilinx, like that. Once the individual modules provides the desired response, we are combined and write the detailed hardware design, detailed software design. First, I am designing for addition operation. Second, I am designing for subtraction operation. Then I am designing our design for multiplication operation. Like that, individual operations design will be designed. Later on, combining all these designs and the final design, calculator design. So for that, I am designing hardware in the detailed process, step by step. Parallelly, if you are designing sequential, means take much time again. So at the same time, parallelly, I am designing software design and parallel doing the hardware design. Once both the designs completed, I am integrating the firmware or software into the hardware by using integrating tools like Prog ISP. By using Prog ISP, I can load this generated C file into X file into the 8051 development board, JADIC Prog ISP, or some integration tools. Here again, once integrated, I need to test the design response, overall design. Here we are checking individual responses, then write the detailed design, then integrating the firmware into the hardware. Then I need to check the response of the product. Is it working in the desired manner or not? For that, I am using different testing tools. Suppose I want to check CAN cable. I am using CAN cable for transmitting the information from one embedded system to another embedded systems. CAN bus. I want to check this CAN bus. Is it the CAN bus for sharing the information? So is it transmitting the data within that time or not? Or corresponding number of frames. Within 1 second, it is transmitting 100 frames or 1000 frames or 10,000 frames. How many frames it will be transmitting? While transmitting, is there any errors? Any problems or issues are there? We need to check. So for suppose CAN bus, for the testing tool is CAN OE. For verifying the response in the CAN cable, for testing that CAN cable, I am using CAN OE IDE tool. IDE means Integrated Development Environment. Okay. So in this, I am using CAPL script, CAN Access Programming Language. So by writing different test cases, I am verifying testing the CAN bus response. In between here also we are using different debugging tools. So even we are not getting any syntax errors, the response may not be in the desired manner. At that time, we can use different debugging tools, on-chip debugging, background debugging mode, Nexus, like that. We are using different debugging tools. Bug means error, D means removing. So remove this functionality errors, not syntax errors. While compiling, we are getting the syntax errors. Even syntax errors are 0, but response is not in the desired manner. So we need to use debugging tools. Okay. So like that, we can test the product number of times. So after first usage, after second usage, after 100th usage, or thousands, after using 10,000 times, is it providing same response, same time period, or same accuracy? Like that, we need to check. Okay, in different conditions. In foreign countries, if any problem occurs while using the device, means the company will bear the that response. They need to pay the amount if any problem occurs, or if a product fails, means the company will provide that amount to the customer if any they file any case. So you need to take care very much. Otherwise, the company will lose lot of amounts. They need to pay to the customers who are facing issue with the product. Then the seventh stage is maintenance and upgrade. Maintenance means, okay, first we are deciding the requirements. Then that requirements is designed using hardware or software to partition the requirements. Then that the hardware requirements are divided into individual parts. Similarly, software requirements are divided into individual parts. Then until getting the desired response, we are repeatedly modifying the code or design. After getting the desired response, we are writing the detailed hardware design, next detailed software design, then integrating the software into hardware. Okay, after integrating, again we are testing the product. After testing the product, we need to provide the support while using the once this product is tested and valid, that product is released into the market. Release the product into the market. While using the device products or mobile phones, whatever the electronic embedded systems we designed, while using, the customer may face some different types of issues. Either software mobile is hanging, some errors are occurred, or some hardware failures occurs, or some software failures occurs. So at that time, the company needs to provide the service centers to rectify that errors. So, is it provides the maintenance? Is it rectifying errors? If you are not providing services, the product who will purchase? So, how much time they are providing supporting to the customers for their product failures? Okay, like that they will check. The company needs to provide the maintenance. Then, if any update is coming, like update in the sense, now I am using 5G mobile. In coming days, 6G will come. At that time, instead of designing the product from beginning onwards, just modify that updating parameter only, 5G to 6G, or 108 megapixel to 200 megapixel, or 2 GB graphic card to 16 GB graphic card. Like that, a processing element, A15 chip to A18 chip. In iPhone 16, we are using A18 chip. Instead of designing each and every parameter again and again, only update the product in the particular parameter point of view. That is upgrade. So these are the several stages involved while designing the embedded system. So embedded system design involves 7 stages. Embedded system design involves 7 stages. First one is the product specifications. Second one is the partitioning the hardware and software requirements. Third one, iteration and implementation. Next, detailed hardware design, detailed software design. Next, integrate the software into the hardware. Next, do the acceptance testing. Then maintenance and upgrade. These are the several stages while designing the embedded systems. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.